Welcome to the East San Joaquin Water Quality Coalition annual member meetings. We have, as we did last year, a series of meetings that growers can participate in. We're also taping this presentation so that those that can't come to the meeting can watch it on the internet. And if you haven't done that before in coming years, you're certainly welcome to watch these presentations or the presentation and get credit for your one meeting a year. The other thing to remember is if you've got people farming for you or leasing ground, you can give them your membership card and they can come to the meeting on your behalf, and that'd be fine with the coalition to do that. There's things changing in our order and based on what's happened with the State Water Resources Control Board. I'll go into that for a minute. So our meetings will be, these February meetings will have May meetings and then in November. And even though you have fulfilled your meeting requirement with today, there's a lot of things that are happening in agriculture in the State Water Board program that are changing, and you'll get a sense of that in a minute. So even though I know we love to go to meetings as growers, you may want to consider coming back in the fall to get an update on what's happening in the State Water Resources Control Board. So before I get into that, though, I want to do a little bit of preliminary. We didn't do an agenda because we waste a lot of paper doing that. So I'm going to just go over real quickly what we have on store for you today. I'm going to give you an update on what the State Water Board has done to our petition, to our order in response to a petition by some environmental groups and actually some coalitions. I'll give you an update on that. And then I'll have Mike Johnson come up and talk about our groundwater monitoring program and the surface water results that we've gotten in the past year. And then we've got Steve Amador from Modesto JC is going to talk about irrigation scheduling and distribution uniformity. And in fact, he's got a demo set up here at lunchtime. We're going to have students over there explaining how you can do this same sort of evaluation of your drip or sprinkler system. So please take advantage of that if you can. And then I've got a local certified crop advisor, Don Chesney, is going to be talking to you a little bit about some of the basics of nitrogen fertilizer management. And then I'm going to go over the nitrogen summary report. That's going to be another piece of paper you're going to be getting from us in about a week or so that's going to request some data from your fertilizer management, nitrogen management in last year's crop year. So whatever I'm talking to you about today is not just impacting the East San Joaquin Water Quality Coalition. I think it's always good to remind everyone that this is just not our coalition requirements. Every farmer in Central Valley irrigated agriculture has to belong to either a coalition or have an individual permit. So this is the map of the Central Valley. There are now 12 coalitions, 13 counting the California Rice Commission, who are under waste discharge requirements with the same requirements that we have. The only difference, and you probably have gotten this from some of your neighbors that are in the other coalitions, they have different timelines. So the implementation of any of these activities, they have it, some of them are a year later, some are 6 months, but whatever you're going to hear today, even the proposed changes are going to impact everyone that farms commercially irrigated cropland in the Central Valley. And you know where we're at there in the center of the map. This is our current status of our membership right now. We're down a little bit because during the change of our order, there was a boundary shift over on the San Joaquin County boundary, or San Joaquin Stanislaus County borders. So some of the acreage that we had went into the Delta Coalition and then also on the west side of the coalition. So we were about 710,000 acres and it's gone down a bit. So we're steady about 700,000 acres. And as you see, about a little over 3,500 landowners, and with this participation, we are able to still keep our dues level at $3.75 an acre. 75 cents goes to, we pay to the State Water Board to pay for the bureaucrats in Sacramento to manage this program. And we anticipate being able to stay at that level going into next year. There's always one caveat in there. Apparently that 75 cents may go up. It's unsure what it will be. Maybe, yeah, I know, real surprise, you know. It may be 90 cents. It may be $1.10, so stay tuned. It gets built into the governor's budget every year, and the Irrigated Lands Program has to pay for all the people in Sacramento that manage this program. So that's what that money goes for on behalf. But as of now, it's looking pretty good to stay steady. We don't see any drastic changes in our program dues costs, and we're trying to hold costs down as much as we possibly can, even going into groundwater. Our board of directors has stayed fairly stable stable. We do have a new board member out of Merced County, Christina Beckstead. I haven't learned her name yet. She's the new Merced County Farm Bureau manager. She took Amanda Priest's place. So we have the County Farm Bureau directors on our board of directors. The county ag commissioners are still participating as non-voting members. And then Wayne Zipser has gone off the board. He's now an employee of the coalition working on our behalf with member relations. So we've got Wayne, myself, Michael Johnson, who you'll hear from in a minute, is one of our consulting groups. And then Jennifer Sanchez, Katie Camptonico, you met when you came in. So just real quickly, going over the membership requirements, you all are familiar with these. We got this farm evaluation. We're on year 3 of that. Unfortunately, there are some members who have thrown those things in the trash a couple of years in a row now, some even 3 years in a row. And the regional board has decided they are going to send those people a nice little letter called a notice of violation. So please, if you get that notice of violation, come to us and let's get this thing filled out. It's a paperwork requirement. I know we hate paperwork, but please get this thing filled out. You certainly don't want regional board enforcement coming after you for not filling that in. And then the nitrogen management plan, we sent that to you last spring. That was supposed to be for your 2015 crop. And then in a week or so, we're going to be sending you a nitrogen management summary, and I'll talk about that in a little bit. Sediment and erosion control plan, that's another one that came out of the blue. We'll talk a little bit more about that in detail. We've got some developments we're hoping that will eliminate the need to have an engineer sign off on that, so we'll tell you about that in a little bit. And then if you're 60 acres and smaller, there are some longer time frames allowed for some of the paperwork requirements. And then we have the annual membership meeting requirement. Okay, so in 2000 dates are running into me now. 2011, when our waste discharge requirements were brought up for consideration and then adopted in 2012, 2 lawsuits were filed, 2 petitions were filed against our order. One by a disadvantaged community activist group, and then another petition by, let me back up, one by the activist group that said this program is not strict enough. It is not fulfilling the water quality protection mandates in the Clean Water Act and the State Water Board program. So they filed a petition, and the way petitions work, if anybody doesn't like a law on the water board, the appellate or the way that you appeal is you appeal to the state water board. So we're regulated by the regional water board. State water board, we call it the mothership, and then there's 9 regional boards around California. We're Region 5. So Region 5 adopted our plan or our waste discharge requirements. These groups didn't like it, so they appealed it to the State Water Resources Control Board. Now this is the same group, you all remember last summer, that revoked some of these pre-1914 water rights. This group is, State Water Board has some amazing authorities. So anyway, this was petitioned in 2012. The State Water Board has been cogitating on this, on our order for almost 2.5 years now. On Monday night at 4:30, they released the revised draft order for the East San Joaquin Water Coalition. And we were the ones that were petitioned because we were the first coalition to get their WDR approved. So they filed, the activists and the other coalitions, the coalition said it was too strict, petitioned our order. State Board has been thinking about it. Monday they released their draft order. And before I get into the details, and we had a member meeting on Tuesday, and I want to repeat what I said, before you get your heart pressure, your blood pressure up, as mine has been lately, this is going to be a slow process. It's not going to, what I tell you today is not cast in stone yet. We've got a lot of a process here to go yet. So what happens is we have a written testimony that the coalitions, our attorneys, the other coalitions will send in April. They're having a public meeting in March. Then the staff gets that comments, they consider those comments, and then they come back with recommendations. It could be 6 to 12 months before this thing gets out of the legal challenges. And then, if possibly what we could do is we could take it to a superior court. We could, or the coalitions could say, State Board, you're crazy. We are going to petition you, and we want to file a lawsuit against you. Then it goes to a superior court judge. Now that may seem like some of us have this knee-jerk, let's sue those suckers, and then it goes to a judge. Well, I don't think I need to talk about what California judges are like. So we need to really think about whether or not we want to challenge this, and this is a board decision we have to make. Do we want to have a judge decide what we should do? And I tell you, initial thought is that's a dangerous proposition to do, is to turn it over to one of our superior courts in California. So anyway, that is the process that has now been kicked off on Monday. Now the other thing to keep in mind is it doesn't just apply to the East San Joaquin Coalition. The state could say this is a precedential order. All the coalitions in the Central Valley are going to have to do what we have outlined for the East San Joaquin Coalition. So again, stay tuned. That's why I mentioned coming back possibly in the fall, because right now, we barely read through this and had a sense of what's in this order. When you went through sign up and coming through, you got frequently asked questions. That's a real brief sort of summary of what the state has done. Give you an idea, so I don't have to go into the gory details of what it is that they're doing. But I will tell you, and this is the part where hold on to your blood pressure here. So the things that they're saying is the coalition members have to sample all the domestic wells on their parcels. And the reason the reason for this is that in the Central Coast Groundwater Coalition 2 years ago, their order was appealed to the state board, and the state board out of the blue mandated that all the Central Coast growers in their irrigated lands program had to sample their domestic wells because of the high nitrate levels. I also manage that coalition over there. We sampled 1,200 wells of our property owners. 30% of them were over the drinking water standard for nitrates. So they looked at what was mandated over there and they said, all right, Central Valley, now it's your turn. So that's one of the requirements that's proposed going forward. The other thing is getting rid of all this high-low vulnerability business. They said it's not fair to the high vulnerability that low vulnerability growers don't have the same time frames, don't have the same reporting requirements, and need to have a CCA sign off on their nitrogen management plan. So again, that's another thing they're proposing. And then the other part of it that's really it's unnerving is the farm evaluations you send to us and nitrogen management plans, the way the order is written, we take your data, we compile it into a report, and we send it to the regional water board. That's not good enough for the state. They want all of our individual information submitted to them in the summary sheet format that you've been completing for us. They want that all downloaded to a public website. So again, this is something we're going to really try to fight back, both farm evaluations and the nitrogen management plan. And then the last thing, the nitrogen management plan that you got from us, they've changed the name to Irrigation and Nitrogen Management Plan. So they have included in this requirement not only a CCA signing off on your nitrogen plan, but an irrigation specialist reviewing how you irrigate. I don't know what the ramifications of that are, other than as a grower down in Fresno County and understanding exactly what I have to do on my ranch, much less all of you with how many acres you have. This is going to be a challenge that I think we've got to figure out and clear-headed. How are we going to push back? What can we win on? What do we give in on? And decide the way forward. But as of now, everything that we're doing, all the requirements, they're in place. None of this gets stayed. None of the requirements are stayed until this is worked out. So this may take a year. It may take longer before it's actually implemented, and we come out and say this is the things that have to be done. Now, you may be saying, what's this coalition doing for me? Why do we pay this into this, and why are we doing this? I just say talk to your dairy neighbors that have individual permits, and you want to know what an individual permit looks like. Those guys are living it, and that is something that I wouldn't wish on anybody in irrigated agriculture. So I still think that doing this coalition approach and managing it in this way is going to be a far better way to get the best deal that we possibly can from the State Water Resource Control Board. Okay, that's enough for the intro. I'm going to hand the microphone over to Michael Johnson. He is our consultant for groundwater and surface water, and he's going to give you a presentation on surface water results that we've had in our coalition sampling.
Good morning. As Perry said, my name is Mike Johnson. I've been your technical consultant since the very beginning, 2003. I've been working for you since then. And as you all know, you're required to attend one meeting a year. And we're required to provide you with some updates on the monitoring results. So far, we only have monitoring results for surface water. Every year I keep promising you that maybe next year there'll be groundwater, and so maybe next year there'll be groundwater, but as of today we have just surface water. So I'm going to talk to you a little briefly about the design, just give you a quick reminder about the design. We'll go through one slide of results. The results are actually pretty good again this year, again due to all of your hard work out there. Then we're going to talk about groundwater. We're going to talk about the trend monitoring program that the coalition is trying to develop and kind of the problems that we have doing that. And then we're going to finish up with a little bit of sediment. Interestingly, I think if you were to talk to Wayne and Katie, this is by far the biggest generator of phone calls to the coalition office and to them. And in fact, it's a bigger issue here than it is farther south in the coalition. So we'll go through that real quick. Okay, so the surface water monitoring design, if you remember, we have 6 zones, and I'll show you a map here in just a minute. Within each zone, there is a core monitoring site, and we monitor at that site for 12 months of the year. In fact, the guys were out just this last Tuesday. You may see the white vans out there collecting water from some of the monitoring locations. We monitor for a whole series of things. We monitor for pesticides. I don't even remember the number of pesticides, maybe 35 or 40 different pesticides. We monitor for nutrients. Nitrate is the big concern right now. We monitor for nitrate and for ammonium. We monitor for bacteria. We monitor for a whole series of metals that are applied. Toxicity in the water. We monitor for toxicity in the water and for a whole series of physical parameters such as the amount of dissolved oxygen in the water, the pH, which is the acidity of the water, temperature, and so on. We have a second thing which I'll come back to in just a minute here. Let's go. Okay, so if I can, yes. So here, it's a little hard to see with the light here, but here are the zones. Here's the coalition region down here. Here's Madera County. So there's a zone here. Merced County has 2 zones, and Stanislaus County has 3 zones. So there's the core zone, is core monitoring site here is Dry Creek at Wellsford. There's a Prairie Flower Drain, and I can't find the other one, and it's not quite worth it. I think it's maybe here, Hillmore Drain. Okay, so those are core locations for the zones in this county. And you'll see here there's a whole series of other kind of dots and circles and so on, and I'll talk about those in just a second. Okay, those are the represented sites. We monitor 12 months of the year at the core sites. If the water quality is good at those core sites, we don't have to go back and monitor at the represented sites. Only when we have problems, and a problem is defined by the regional board as finding toxicity in the water, bacteria in the water, or some chemical, Moorsban for example, at a concentration higher than the regional board allows. If that happens, then we go and monitor at the represented sites. Right now, across the entire coalition region, this region, the Stanislaus County included, we actually don't do a lot of monitoring at those represented sites. They are, the water quality at the core sites is quite good, and we are saving a lot of money by not monitoring a lot of other places. And as Perry mentioned, one of the reasons you've been able to keep your dues as low as they are is because you've done the work to keep that water clean. Okay? 10 years ago when we talked about this, I said, if you clean up the water quality problems, your dues will go down. We won't spend that kind of money, and that's happened. You guys have done a great job. We also have what are called management plan monitoring. So if we have a problem at a site that's persistent, we have to develop a management plan. We have to write a plan for the regional board that tells the regional board how we're going to fix that problem. And then we have a 10-year compliance schedule. We have to have that problem fixed within 10 years of its detection. Okay? So we have 3 different kinds of monitoring, and I'm going to show you. So here again is here's like the core site, Cottonwood Creek down in Madera County is the core site. That we have a whole series of other sites in here that are represented for management plan sites. It's not that important. Here's the important part. Okay, here are your results for the last monitoring year that we've got results for. So as you can see, just like last year, here on the right, these are all these physical parameters. We have lots and lots of problems with the physical parameters, but those things aren't to worry about, okay? When you have very little water, it's not flowing, and it's the middle of the summer when it's hot, you're gonna have lots of DO problems, okay? That has nothing to do with you. There's one site, Prairie Flower Drain, that has had some problems over the course of time. The biggest problem is this chlorpyrifos. That's Lorsban. That's the active ingredient in the product Lorsban. We had 6 exceedances, okay, which means that we detected that chemical in the water 6 months in a row at a concentration higher than the regional board allows. The reason we did that is because there was basically no movement in Prairie Flower Drain. That water sat. We detected the first exceedance in March. We detected it again in April, May, June, and so on. Okay? So that's basically the same. We're just sampling the same bit of water month after month after month. Okay? And there's some other ones. For example, molybdenum. Molybdenum, we always find molybdenum. It's a metal. It's found nowhere else in the coalition region, but for Prairie Flower Drain, it's naturally occurring. Okay? Again, it has nothing to do with, you don't apply molybdenum, right? Okay. These are your results. The bottom line is that we do have some issues here. There are few issues. Our water quality in general is actually quite good. Okay? Which means that, can you guys see? Which means that your dues stay low. We don't have to do a lot of extra monitoring. We don't have management plans, and we don't have a lot of extra monitoring represented sites. Okay, we're going to move on here. Groundwater. We started the groundwater, as soon as the order was adopted in 2012, we had to start jumping on groundwater. The coalition developed a groundwater assessment report that was finally approved, and when that was approved, we have to now develop a groundwater trend monitoring program. That trend monitoring program, the goal of that is to document water quality, groundwater quality, on a regional basis. So we need to find wells across the entire coalition region, monitor them once a year, once every other year, once every third year, we're not quite sure yet, and look at this over the next 5 to 10 to 20 years. Let's look at groundwater quality. The task that we've been trying to complete here to this point is to identify the wells. What wells are we going to monitor? What we've tried to do is to find wells that already have a history of monitoring, and again, the monitoring concern is for nitrate in drinking water. We have identified a whole series of wells. They belong to the municipalities, small towns, bigger, Modesto and Turlock, for example, school districts, campgrounds, churches, all these different wells that are part of have to report to the Division of Drinking Water at the state board. They have a monitoring history for nitrate. We have contacted lots of those entities, and we've asked them if we could have their well completion reports. Because in order to use their well for this program, we need to know the depth, we need to know the screening interval, we need to know the well construction, and so on. We have not met with any success, as you might imagine, for good reasons. There's a lot of issues out there dealing with groundwater, pumping and all of that, and people are reluctant, all these entities are reluctant to give us all of the information about their wells. We may, at some point in time in the future, have to come back to members and ask members for permission to monitor their wells. We would prefer not to do that for 2 reasons. One, there's no history of monitoring your well for nitrate, basically. There may be one sample at some point in time, but if we wanted to establish, improving groundwater quality, demonstrate that there's a trend, we need to have a record of monitoring over the course of time. And member wells don't have that. The other thing is that member wells are not always located and always screened at the right depth. We have a particular depth that we're working at. And we really need wells that are pulling water from that aquifer, and not every member has a well that meets that requirement. So, but at some point in time in the future, we may have to actually come knocking on your door and ask if you'd volunteer your well. But that's out into the future, and we're not there yet. Okay, we are supposed to deliver, we were supposed to have delivered our final list of wells last July or somewhere around there. We're hoping to get a list of wells by this summer, but we're still working. Monitoring, last year I said, yeah, we'll have some results for you next year. Well, okay, same story. We may have some results for you next year. Okay, one of the things, I was going to show you this real quick. Each of these areas here, the groundwater consultant that the coalition has contracted with has all of these little, this is the orange, the reds, and these are greens, if you can actually see the color there. And we need wells in each of these, at least 2 wells in each of those zones. Okay, so you see there are a lot of zones there. We had a lot of wells that we need to identify. Okay, the other thing we need to do as part of our groundwater program is what's called a management practices evaluation program. One of the things that the regional board has said over the course of time, they said this with surface water, they're now saying it with groundwater, is that we always say, hey, growers are doing what they need to do to be protective of groundwater, right? There's backflow prevention on wells and all of that sort of thing, and of course the regional board has said, as they did with surface water, show us the data. You have to show us information, real hard information, numbers, that demonstrate that the practices that are in place are protective of groundwater. So this program, that's the goal of this program, is to go out and do some studies to demonstrate that the practices that growers are using, members here are using, are protective of groundwater. The work plan that we've been working on, the work plan, it's due this June. The studies will start probably late in 16, more likely very early in 2017. That is going to be a relatively expensive process. We may need to do some field studies, and then we're going to do some modeling, sort of the combination of the two, and try to keep your costs down. But right now, the regional board has said, you need to demonstrate that these practices are effective. So that's this program. The other sort of bottom part of this, the bottom line, is that if we come out and identify that there are certain practices which are protective, the regional board, there's a statement in the order, the waste discharge requirements in your order, that says those practices must be adopted by members. There isn't going to be a practice that everybody's going to have to do. There's going to be a whole suite of things, and you can select. You're just going to have to demonstrate that the practices that you're doing, you have something in place that's protective of groundwater. Okay, let's move on to sediment. And before I get started here, when I gave this presentation in Madeira a couple of days ago, I started to work my way through it, and there were hands shooting up everywhere. So if you've got a special case, if you want me to sort of look at your maps and that kind of stuff, we can do it on the side here after either after the meeting or after I'm done talking. But here's what we've got in general. We had to develop a SEDIR, Sediment Deposition and Erosion Assessment Report. And that basically identified the members that were considered at risk for erosion and then the movement of that sediment off into surface water. And there were lots of things that put you on that list. One is if you've got high slopes, you got erodible soils, and you got some sort of long hillside, and long is a relative term, you ended up on the list. But there were also any parcels that were adjacent to surface water. The regional board came back and said, you need to put that in, because we don't think you've got enough people, enough ranches on your list. And we said, well, that doesn't, you just can't lump everybody in there and say, just because you're adjacent to a water body, to a creek, that you're going to discharge. And they said, put them in. Everybody has to go in. So that throws you into that category. The other thing is, if you didn't complete a farm evaluation, you automatically went into the pool. So that's another reason why, if you haven't completed one or you didn't turn this year's in or whatever, you need to get this thing in, because on the first page there's a question number 3, And that question says, do you have the potential to discharge sediment? Anybody who said yes to that question, who checked that box yes, they went into this group as well. Now, what we've realized over the course of time is that there has been, when you look at that question, you say, do I have the potential to discharge? And you think, well, if I get that 500-year rain event, then yeah, I suppose I could have some stuff run off. That's not what we're looking for here, okay? So, but if you answered yes, and I'm going to give you some options here in just a second as to how you can sort of work around that. And if you fall into any of those categories, you were sent a sediment and erosion control plan. You have to fill it out, and you're required to get it certified at some point in time. Okay. Here are your options. The first option is, if you're on a slope and you got some bare ground, then you need to fill one of these things out and get it certified. Okay, so if you've put in a new orchard up in the hills here and there's the potential for that during a rainstorm for stuff to run off, you legitimately need to get this thing filled out, completed, and get it certified by an engineer or whomever. Okay, so there are certain members for whom this is applicable. Second, if you haven't done that farm evaluation, in other words, if we had to automatically put you into the group because we don't have a farm evaluation for you, fill it out, tell us that you don't have the potential to discharge, and you get tossed out. You don't have to complete it, okay? Third, if the response to that question 3 is incorrect, so in other words, if you said, yes, I think I have the potential to discharge because maybe, possibly in a big rain, there's something that might run off, but generally you don't think that that's correct, there's a form that you can go online, I believe it's online, and you can download it, you can fill it out, you can provide an explanation for why that question was answered incorrectly, and that will go on file, okay? And the other thing is that Perry mentioned this briefly, one of the other things is that the coalitions are working with the NRCS, Natural Resources Conservation Service, to develop ways to get somebody out to help certify a plan for you. Okay, what they've promised that they're going to do is they're going to develop a training program for RCDs. So within an RCD, somebody will be trained, they'll come out, they'll help you develop the plan, and they'll do it for a nominal cost, nominal fee, okay? I'm not trying to take business away from any engineering firm, but at this point in time, first of all, it's an expensive thing to do. I'm not sure that you could get an engineer out here in enough time to actually get it certified before the end of the winter anyway. So I can't tell you that you shouldn't fill it out and get it certified. That's the order, that's a requirement of the order. But what I'm telling you is that at this point in time, if there's some question in your mind as to whether you really legitimately need to do this, fill it out. So the definition, the question here from the front was, what's the definition of if you're adjacent to the creek, right? So does adjacent mean 2 inches, 2 feet, 2 miles? And the answer is, if your property goes up to the creek, the edge of the creek, that's adjacent. If you're one parcel in, that's not adjacent. So if you got somebody between you and the creek, you're not considered adjacent. Yeah, sorry, Perry's telling me he's giving me the hook here. I'll be happy to answer any questions, here either after the meeting, during lunchtime, whatever. But we're running a little behind, so I'm going to turn it back over to Perry.
Okay, thank you. Again, my name is Steve Emitter. I teach here at MJC, and I'm the head and the one that's starting our irrigation program. I'm going to talk to you briefly a little bit about one, how you can take some measurements on your properties and take some evaluations of your irrigation systems, and then use those numbers or use those results and make some simple improvements. What really happens is, we have engineers that design irrigation systems. They're installed. They've been in place for 20 years, and they start to decline in their efficiencies and their uniformities. And us as growers, we can make some quick adjustments, or we can make some repairs and bring those back up to standard. for a couple reasons. One, I think for us to save some water, and two, for us to keep track of everything that's within the water, considering nitrogen and some other things, and really keep control of and manage that to the best of our ability. And so a couple of the quick definitions off the start. Irrigation efficiency. I always consider irrigation efficiency as a combination of a couple things. One, irrigation efficiency is how good we are as irrigators. Are we applying water at the right time, and are we applying water when we need to apply water? And another part of that is how good the system is. So irrigation efficiency is really how good we are along with how good the system is. We have some spray loss, evaporation loss, surface runoff, some percolation, so forth in with some of this. Distribution uniformity is the one I'm going to talk most about, and how we can make improvements in the system, because I hope we're applying water in the amounts that we need to apply water. And I'm hoping we're applying water to fill soil moisture deficit, and we're not over irrigating, and we're managing some of those things. And as you can see, example of a good distribution uniformity, everything's pretty even. All the plants in the field get everything that they need, and it's 100% even. And I'll let you know that never happens. And example of a poor DU over there, as you can see, some of that water is applied deeper in some spots than in others. And so the problem with that DU, or the poor DU, is you've all driven and you see the corner of the field, and it seems like there's some corn there that never quite gets the water it needs to. And so the production's not there along with the rest of the field. And so we over-irrigate to make sure we get water in that corner, and that's really what happens. And so what happens is the application depth, we're under-irrigating parts, but in saying that, we're over-irrigating other parts, and we're driving it past the root system, we're driving it into the water table, and that's where we're running into problems, both wasting water, wasting nutrients, driving the nitrogen down, and just using it inefficiently. Okay, I put a quick example up here. If we go to CMUS or CMUS, or the MJC has a weather station as well that we can gain ET data as also. Evapotranspiration rate for almonds, 40 inches a year. And again, these are just numbers. We did some estimating. We flood irrigated field with a distribution uniformity of 75%. In order for us to get 40 inches of water in every spot of that field, we need to actually apply 53 inches of water to make sure that each spot gets the 40. Well, in doing so, we just put out a little over an acre-foot extra water to make sure that we covered all that. And that's an acre-foot of water on each acre that we really should keep control of. So if we look at some distribution uniformity across some different irrigation methods, under-tree sprinklers actually do a very nice job, and linear move and some sloping furrows and so forth. And these numbers up here we see are I guess I call them the goal. They're the goal. If we have some under-tree sprinklers, then we need to be pushing towards 90%. And this is the perfect system. The one that's designed perfect, the one that's maintained perfectly, the one that everything just lines up. Pretty hard to obtain, but those are the goals that we're going to try to reach. And so a couple things we can do to measure our own distribution uniformity. If we take a look at the movable line that we put out here in the middle of the field, and the catch can buckets that we put out there, we run the sprinklers. We place catch cans. Usually the magic number is 24 cans. We put out more. We put out as many as we possibly can within that area. That way we can get a better representation. We put them in an equal grid. We run the sprinklers until we get a representative sample. We measure the amount of water that is caught in each can. The more we test it, the more accurate we can be. This is a real simple method. We can take a couple other things into account. We can actually take flow rates out of each sprinkler. And that's really pretty simple to do as well. We just direct the water out of the sprinkler through a hose into a bucket. If we hit a stopwatch, we time it, and then we can determine a flow rate that's going into that bucket. And then if we have one sprinkler, that's putting out 2 gallons a minute, and we have another one that's putting out 3 gallons a minute, and another one that's 1.5, then we have some variation that maybe we should take a look at. Okay, so we collected it all. We took measurements of the water. Excuse me, before I show you the math, we actually, I like personally to take measurements from some different locations. I like to take measurements from right by the main, right by when it first enters the field. I like to take some measurements out in the far corner of the field and take some measurements, kind of a middle representation, and kind of average all those numbers and see where we're at. This is a distribution uniformity work we did in around Delhi, just off the east side of Delhi in a grower's orchard. We came back and we measured the water that we collected in those buckets, and we took those 24 samples and we ranked them from the greatest volume to the smallest volume. The math here is called a low quarter distribution uniformity calculation. We take the average of the low quarter, and we divide it by the average of all of them. So you see in this case, the lowest quarter value is 89 milliliters is the average. We take the average of all of them, which was 101. We do a little bit of math and we come up with 88%. And we can use those numbers to set a baseline for where we're at. This PowerPoint, by the way, is all on the MJC website. You're welcome to look at it. Shortly we'll have some Excel spreadsheets that will allow you to do this math. Well, we'll do this math for you as well. Okay, so that was a sprinkler. So we came up with a distribution uniformity for a set of sprinklers. Now, a drip or micro sprinklers are it's a little different because we're not covering all the ground. And so really it's not a distribution uniformity, it's an emitter uniformity. We are determining how much water is coming out of each emitter or each source. And it's really calculated the same way, but it's very, very similar. And instead of using catch cans, we just use a graduated cylinder. We pick up the emitter, we put the emitter right in the graduated cylinder, we time it. We figure out the flow rate out of that one emitter, and we will do that across the field. I think a lot of people consider that, I got a row of drip emitters, and they're putting out 2 gallons an hour. They're all going to be the same. I think if you ever did this, you would be surprised at how different they really are. Even brand new fields, we've seen brand new fields with significant significant differences between emitter emissions. This is a uniformity test we did at our Beckwith Ranch with a set of grapes. We have a stack of 24 buckets. We get 2 people. We put a bucket underneath the first emitter. We hit a stopwatch first, put a bucket under the emitter. We count for 5 seconds. We put a bucket under the second emitter. Another 5 seconds, we put a bucket under the next emitter. And we work our way down the field. We get a representative sample. We come back. We pull the first bucket out. And after 5 seconds, we pull the next bucket out. And so each bucket is under the emitter for exactly the same amount of time. Makes it a little more efficient, a little easier. Then we come back and we do the same math that we did previously, and we determine a emitter uniformity. Flood irrigation, furrow irrigation, border strips, whatever you want to call them. It's difficult. It's much more difficult to determine a distribution uniformity. It all comes down to opportunity time. How much time is that water on top of the soil? And the longer it's on top of the soil, the more they will infiltrate. And so what we do is we start the water. And we set what's called the advance time. And we calculate or we time how fast that water moves across that soil top. So we apply water, and we do a time distance graph, and we come up with what's called the advance curve. We then shut the water off. And then we calculate and we time the amount of time water takes to recede. The recession curve often stays pretty consistent. The advance curve often fluctuates. If we're irrigating a little slower, we're putting out less water, the soil's just been worked up, it's infiltrating quite a bit more. So we have an opportunity time, and we try to keep those two lines exactly the same, so that water's on each piece of ground at for exactly the same amount of time. What has tendency to happen is if we irrigate really slowly, and we want the water to go out there slowly for whatever reason, we open extra valves, we lose the head from the canal, whatever the case may be, we come up with an advance curve that's much steeper because it takes a lot longer for that water to get into the field. The recession curve stays roughly or relatively the same, and now we have an opportunity time that is different on one end of the field than it is on the other end of the field, and so one end of the field receives more water than the other end of the field. Okay, let's talk about how we can make some simple improvements. So we know what the DU number is. We have a percentage. And so now we're going to go out there, and with sprinklers and drip and micros, we're going to check them at startup. We're going to look for damaged plugs, plug sprinklers, plugged emitters, broken emitters, stuck sprinklers, repair leaking fittings and gaskets. All of you have seen aluminum pipe that seems there's more water coming out of the joint on the aluminum pipe than there is coming out of the sprinklers. And so I think it's important to replace those gaskets and do some maintenance on that. Look for plant interference. I've also seen sprinklers running with oats that are taller than the risers on the sprinklers. And so the uniformity there, the water's not getting where it needs to go. We can also talk about nozzles a little bit, about wear in the nozzles. Nozzles wear. If you get sand in your water, the filtration system's not picking it up and you're putting it out there, you're going to wear the nozzles. So you can see that bottom picture has got a big groove in the nozzle. We can change them. Mismanagement. Repair nozzles with the same sprinkler. Repair nozzles with the same, go back with the same. I'll let you know that we have done a number of uniformity studies with students. We go out in the fields and we see a lot of stuff. We did one study and the uniformity was very, very low. It's about 40%. We talked to the grower. The gasket had failed in the filter, in a screen filter, and it was leaking like a sieve. And we didn't even take that into account, but we were talking to him and he said, yeah, one day, he goes, I felt that one part of the field wasn't good enough, and so he drilled the sprinklers out. And so what has happened is an engineer has designed that, hopefully, appropriately, and now we're overriding some of the things they've done. And so we need to go back with the same sprinklers. We need to go, we've done uniformity studies on micro sprinklers, and done a study of 25 sprinklers and had 4 different styles and sizes in one location. And it's important to keep those the same. Clean and maintain the filters, flush the lines every month, keep application rates, infiltration rates less than infiltration rates. If you got water puddling up, you got water running around on the surface, maybe slow that water down a little bit. I think that's a design thing. I think the guy who designed that system should have taken that into account, and that should not be a problem. But if you have water puddling up for sprinklers, then maybe we're putting out too much water too fast. Irrigate at night, irrigate with less heat, less wind, power cost. I think everybody's doing that most of the time because I think that gets expensive if you start irrigating during the day with a pump. If the field has pressure flow problems, we can go with pressure compensating sprinklers as well, sprinkler nozzles as well as emitters. Irrigate longer sets less often. If we're irrigating with micros and we're putting water out every day, that soil surface is staying wet every day. And so the evaporation coming off that field is every day. If we irrigate a lot of water with a permanent set type of sprinkler system, we cover more ground and it evaporates more at first, but after about 3 days, that evaporation that surface water is really gone. So it's really not evaporating off that surface anymore. And so if we irrigate a little more, longer sets, we have a tendency to have a little bit less evaporation. Yeah, we had another one, and we talked about pressure compensating, and I think the emitters and the sprinklers and the quality and the engineering behind those is really improved in the last 10 years. We did another uniformity study, and a grower was having problems with micros plugging up. And so the solution there was to take all the emitters apart and remove the pressure compensating diaphragms from them. And they no longer plugged up, which was the goal, but the problem with that is now the engineer put in pressure compensating devices so that it would take account for elevation change and take account for pressure change and so forth, and now we just took all that out, all that work that was done, we take that out. Okay, surface irrigation, how we can improve surface irrigation. We can grade it, we can level it. I think everybody's familiar with that. It's expensive, I understand that, but the more control we have on how level that ground is, the better off we are. We can put a little bit of slope to it. We can get the water moving a little bit faster. Usually with furrow and with flood irrigation, the faster we can irrigate, the faster we can keep that advanced curve line straight and flat and low, the better off we are. Much, much better to put a lot of water out fast than it is to do it slowly. Okay, and so by doing that, we can grade property that has a slight downslope to it. We can get that water moving a little bit fast. Tailwater systems, I don't see a lot of them. I don't see a lot of tailwater systems around here. I don't know if that's because our water is fairly inexpensive and the cost of a tailwater system it really doesn't warrant that. Tailwater systems are in flood or in furrow irrigation. We have all the water run to the end of the field, and then that water is collected. Usually what happens now is we turn the water on, or we run the water down the furrow, or we run the water in a flood situation. We wait for the water to get 2/3 down the field, and we shut it off. We shut it off and we let it coast to the end. And it's really hard to gauge your water that way. It's really hard to gauge your water that way. And I find with some of the guys with sprinklers and some of the guys with micro, I ask them, how much water did you apply? You irrigated for 12 hours, how much water did you apply? And sometimes I get the answer, so many inches. Oh, we put out 3 inches of water today, and that's great. The flood guys, I find, not all, but some, they put the water out and said, how many inches of water did you apply? And we don't know. We had the head from the district, we opened it up and we let it go, and when it got almost 2/3 to the end, we shut it off. And so it's really hard because we're not really measuring what we're putting out. We're just putting it out so it gets out there. And I think it's better if we measure it. I really do. And so the tailwater system allows us to measure it. And so what happens is I know that if I run a gate open with a certain amount of head, and I run it covering a certain amount of acreage, and I run it for a certain amount of time, I can do a little bit of math and I can say, you know what? In the next 3 hours, I'm going to cover this ground and I'm going to put out 3 inches of water. So what we do is we just turn it on and we watch the clock. We don't watch the field. We let the water get down all the way to the end. If it gets all the way to the end, it goes into a tailwater system. It's collected. We run that for 3 hours. That 3 inches we're putting out. The tailwater system pumps it back up into the line, and then it's recirculated across the top of the ground until it's all infiltrated. It's expensive. It takes out a corner of the field. You're collecting water in the corner of the field. That's not conducive to cultural practices. You got that in the corner there, and there's some other problems associated with that, weeds and some other things. But on the other hand, I think it allows us to control that water a little better. This is my opinion and some of my experience, and looking some of these fields and talking with some of these growers, I see that flood irrigation can be very efficient, and I've seen growers do it very efficiently, and I really think that flood and furrow irrigation have a bad rap. I think they have a bad rap. I think everybody says, you know what, they're wasting water. They're wasting water. Let's use micros or sprinklers. Let's save water. And that's not always the case, because I find guys that do it very efficiently. I also find guys that do them very differently. I mean, very inefficiently, I should say. Back to the flood improvements we can make. Run faster. Run the water as fast as you can in a non-erosive flow, meaning you're running it down the furrows. As long as you're not moving dirt with it or soil with it, then that's okay. Run as fast as you can. Make them a little shorter, make them a little narrower, manage wheel traffic. If you have a tractor going down one set of furrows and they're compacting that ground, and you're running water down all the furrows, the ones that are compacted by the wheel traffic, that water is going to move a lot faster than the ones not compacted by wheel traffic. And so you got to kind of manage some of that. The use of torpedoes, which is really just a heavy weight you drag down when you first put the furrows up. That first furrow irrigation takes a long time. It takes a long time because everything's open, that soil surface is open, it infiltrates a lot before it actually settles. And so we run a torpedo or a weight down there to compact it a little bit. Test for distribution uniformity. Make some improvements. Test again. See if your improvements did any good. Test every so often. At MJC, we're looking at a couple things. We're looking at, in the near future, to have students work in internships during the summer and come do distribution uniformity work free of charge. And I think that's a learning experience for my students, and I think that's a service that we can provide for growers. And so look at that coming in the future. MJC has a website. If you Google MJC irrigation, it will come up. On that page, there's one that says educational material, and you will see this slideshow, and you will see some you'll see this slideshow, as well as you will see upcoming slideshows and some Excel spreadsheets to help you calculate some of this math. In addition to that, MJC, we now have a weather station. We're calculating ET data. We are calculating soil moisture in our location. We're calculating precipitation rates and so forth. If you go there, there's a link there. You can click on it. The weather station is on West Campus, right outside this building, and take a look at it. If you have any questions, my contact information there as well. I think my time has come to an end.
Okay, thank you, Perry. As he noted here, I work for Stand Farm Supply. I'm also a licensed civil engineer, so I deal with and have dealt with the erosion control plans. So I handle all of the environmental concerns for Stand Farm, and we'll get started. Okay, the efficiency of nitrogen, why is it important? You all hear about it, you've all seen and read about it. It is obviously an expense to all of your cultural practices. We can reduce costs, as we'll see later on in the slideshow here, with improved yields. Plant health is a huge issue because we get not only pest resistant, we also get disease resistant with higher degree of plant health. And of course, as everybody's mentioned here, the groundwater protection is a huge, huge issue, and that will never go away. Sustainability, you hear that word all the time, many, many different definitions, but it is an important concept. Okay, this slide was made by a colleague of mine, so he's put it together here. But anyways, the timing of the nitrogen efficiency, again, is critical. Type of nitrogen used. You all know the different sources of nitrogen that you use depending on your crop. The total number of units supplied. Of course, you can get that from either your crop advisor or extension or whoever else you work with. The volume of nitrogen applied at any one time, again, a critical data set, and the calcium content is also pretty critical. You'll want to look at that when you do your soil chemistry. Not only do you want to do your soil chemistry, you want to do your water chemistry, as we'll see later, and your tissue tests too, to see where you're at with regards to nutritional status. This slide here shows us that the timing of application is critical, and probably a lot of you, if not most of you, are growing almonds. We see here that the nutrient demand is occurring right during these months. This is when your trees are hungry. This is when you want to feed them the nitrogen. This concept has been around for a while. And it's a critical concept because a lot of time, or it used to be, that guys would apply back here after harvest. They would put down nitrogen, and then knowing that the springtime would come and the trees would take the nitrogen up. But now with different experiments that have been done, we find that the nutrient demand is taking place right here. And you can see some other 4 other data sets here. So again, a critical issue. I can't stress this enough. And it also applies to all your other crops that you may be growing, not only almonds, but walnuts, pistachios, and then your row crops too. This data can be found from extension or publications from other states. So it is critical to know when the right time to apply is happening in your fields. This is just another slide here showing corn. We have degree days down here. These are heat units, and the nitrogen uptake on this axis here, pounds of nitrogen per acre. Just showing you again that the corn plant is going to take up nitrogen when it's at certain times of its growth stage. V standing for vegetative, R standing for reproductive. So you can see on this slide, again, it's a critical issue to apply the nitrogen when the plant is needing it. Okay, application to crop demand, another critical issue. Okay, here we find that you're probably all familiar with these different types of nitrogen fertilizers. Most of you are probably familiar with UN32 and CAN 17, anhydrous, urea, aqua ammonia, which is basically just anhydrous in water. So, and these are the percentages of nitrogen that are found in these different materials. With regards to leaching, as we'll see here in a minute, your ammonium is going to be the material that's going to stay in the soil longer than the nitrate. This material here has both ammonium and nitrate, CAN 17, both ammonia and nitrate. So later on in the slideshow here, we'll see the difference. Okay, leaching, of course, the concept we've all heard about. Nitrate is a negatively charged molecule. I've done hundreds of studies in this county and San Joaquin County on nitrate loading. It's what I call an elusive animal. It can change, it moves, it does all kinds of different things in the soil environment. But knowing that it's a negatively charged molecule, it repels from a negatively charged soil particle. So that's what keeps driving it down through the soil profile because of gravity. Again, it's not absorbed because of the negative charge. You've all taken 2 magnets together and south pole to south pole, and they repel each other, and that's what's happening here. So we see water moving down through the soil. It certainly can carry nitrates. It also carries a lot of other things. Chloride is very mobile in the soil environment, probably more so than nitrate. Okay. Your units, of course, pounds per acre. Again, your crop advisor or extension or whoever you're working with, you'll have to know that. That's another critical issue. Nitrogen needs of different crops here. This is readily available all over the country, in fact, really all over the world. It varies, and so it all really depends on your experience and your observation over the years of what your yields are. So based on what your yield, you can see what your nitrogen need is. Again, crop demand, we talked about that. Split applications, this is another issue I know you've all heard about. You basically want to spoon feed your crop, and it's probably easier said than done, but you've got to know what's happening in your soil, in your water, and the tissue. And by doing the chemistry on those things, you can determine what your split applications are. You just not only determine what the split applications, you've got to do the calculations to know what they are, because you don't want to apply a certain amount here, a certain amount there, and at the end you realize, oh, now I'm way behind, now I've got to put in or on more than what is needed. So it has to be or should be calculated out. Calcium is a pretty important part of the soil environment. Loss of nitrogen efficiency once the base saturation falls below 60%. Magnesium is another critical component of the soil. Higher magnesium, you probably have seen if you get magnesium too high in your soils, particularly if they're sandy, they'll tighten up and you won't get the water penetration that you should. A little bit of notation on the effects of calcium. Every pound of excess nitrogen leach removes 1 pound of calcium. Calcium is an important concept or an important part of your soil. And these are the other issues here that are listed that what effect calcium has on your soil environment. Okay, this pump and fertilizer or fertilize concept, in civil engineering, environmental engineering, there's a concept called pump and treat. The folks in Sacramento, the regional boards, they understand pump and treat because we've been doing it for decades. Our industry is going to call it pump and fertilizer, or fertilize. It's a concept that the regional board people understand. It really is a good way to approach this problem. Your nitrogen in your well water is a useful source of nitrogen. You really should know it. And also if you're using district water, you can get a lot of that information from the district themselves. They normally do the testing on their water. Since we've been in a drought, a lot of that district water has to have been augmented with pumping. So the district's very concerned about what's going into their laterals. But you should know what's coming out of your well. And people have asked me many times, well, when should I test my water? Well, you should test it at the beginning of the irrigation season, and then maybe a third into the season, and then 2/3 into the season, and then at the end of the season, and that'll give you a baseline. Then the next year, just maybe do it at the beginning of the season, because as we'll see here, it is an important issue, and it's money. It's basically free money, and it's a good way to show the regional board people this is what we're approaching, and this is the way we're going to mitigate this problem or potential problem. Here we have an example of a well water with 35 parts per million of nitrate nitrogen. This is or has been a huge source of misinformation. There's two ways to describe nitrate: as nitrate nitrogen in this notation, or just nitrate. Know what your laboratory is giving you. If it says nitrate on your test results form, it's probably just nitrate. But if they have nitrate nitrogen, it's a whole different calculation. This is the conversion factor here for nitrate nitrogen. It's 0.031, I believe, to convert to pounds of nitrogen per acre inch applied. And then you know your inches applied if you work in feet instead of inches, then you would take that conversion factor and obviously multiply it by 12. Again, the concept of pump and fertilize well water nitrogen, it really is the cheapest. It's in your water, if you have it. Of course, as been said earlier, excuse me, some wells you won't have any nitrogen or nitrate. Other wells may be heavily laden. This is why it's an important concept. It's cheap nitrogen. So the contribution of nitrogen should be subtracted from the total nitrogen requirement. So you're applying maybe compost or some other organic matter. You've got nitrogen in your well water, and also you've got the fertilizers that are applied. That all has to be calculated out, but your nitrogen budget, this water should be subtracted from that. Okay, apply multiple times. You're basically wanting, and it's a delicate, difficult subject to approach, is this spoon feeding concept, but it has to be calculated out. Your crop advisor extension, as I mentioned, can help you with that. And it looks kind of complicated, but really on the surface, it's really not too bad. Know when you want to use ammonium or nitrate. Again, that's going to be your preference. It's going to be an economic issue, but you should also be talking with your crop advisor about what is preferable for your crop, and create a calcium-enriched environment in your soil. So that's it for me. Any questions? Yes?
Can we go back to the chart of the timing to apply the for almonds?
For almonds?
So the next hit is from April to July?
Yes. That's when the trees are needing it.
Okay, if we usually apply one time and then we flood, is that pretty much all that it's going to be?
Well, it's going, if you flood irrigate, you're going to put what's known as a head of water on your soil surface, and it depends on the amount, as was mentioned before, how much you're applying when you flood. But it's better to, as we talked about, spoon feed it out if you can. But you've got to know your chemistry. You've got to know the chemistry of the water, the chemistry of the soil, and correlate it with the demand on your trees. The tree is will take that up, and there's a thing called luxury consumption. The tree, if there's more than what the tree needs, it'll still take it up, but then it's going to force it to vegetative growth. And you don't really want that. You'll have a nice, big, beautiful green tree. You want reproductive. So it's really a balancing act, but you've got to know your chemistry. Any other questions? Okay.
Okay, thank you, Don. Okay, give me 5 more minutes and then we can go out, eat lunch. And the reason I'm holding you is that we got started a little bit late, but we are also going to be having the nitrogen report summary sent to you, as I mentioned earlier. And I want to give you a couple of, just run through it quickly to show you some of the basics of it. We've got our staff, Wayne Zipser and Katie Camptonico, that can help you out if you've got any questions. They're available to help fill this out. This is what the form looks like that we mailed to you last year, and I just want to focus on a couple of important things. This is the cover of it. Inside you got elaborate instructions that you can look at for reference on what each square means. But this is what the summary report's going to look like. Very simple, one-page document, and there'll be some associated paperwork with it. One of them that's going to be very important is all your APNs are going to come back to you that you have registered in the coalition with the crop that you've indicated. So what you want to do for the management unit is, and I'll use a very simple explanation. If you've got 1,000 acres of almonds and you use the same amount of nitrogen on there, you have one management unit. You're going to fill out one line on this form and you're done. We've all done pesticide use reports. You don't need to do it like you do a pesticide use report. We have every block and all these just different, the mess. I've been doing those things for 25 years. I have 20 acres and I have more paper from that little 20 acres than you can imagine. So when we developed this, the idea was go for a management unit, put these, when you're using a consistent amount of nitrogen, indicated on that support sheet that these are the APNs in the acreage in my management unit. Now if you want to go the other way and put all your field numbers in there, that's your prerogative. But the main thing is keep a management unit consistent year after year. Try to set up your maps and your reporting or tracking of this information by the management unit. And then the crop, of course that's pretty basic, but we are going to include a crop sheet in there because we have 400 crops in our coalition region. The easy ones are almonds, walnuts, and whatnot, so we know those, but some of these specialty crops, we want to make sure we have, again, consistent designation of what you have. You have citrus, that's different from mandarins, different from lemons, so we want to make sure that those types of things are broken out. Total acres in the management unit. And then this is total available and applied pounds per acre. That's the number we want, is pounds per acre. We don't want your total amount of nitrogen you put on your whole 1,000 acres. Pounds per acre average that you apply. And don't be an accountant on it. Give us an average pounds per acre you put on that management unit. And then a formula that we're going to have, and I'll come back to this, is A over Y. If you remember on that form, you saw on the corner is something called N removed. So the regional board wanted us to put that in there, even though we don't know what that is for most crops. You know, the university has done some studies on almonds that say almond tree uses 68 pounds of nitrogen per acre. So they consider that the amount of nitrogen that is removed off the crop and stored in the trees. Well, we don't have that for most of our crops. So we convinced the regional board that we were going to do a different calculation called A over Y, which is applied nitrogen divided per acre divided by your yield per acre. So you're going to have a number that comes out that's 0.3, or it's going to be almost a meaningless number to you, but what we're going to do is compare that number to other almond growers in your township and other almond growers throughout our coalition region. So that's why it's important to do your A over Y calculation on the applied nitrogen over your yield. And we'll have a worksheet in this mailing that'll help you explain. The other thing that's real important, easy for almonds and walnuts, we all get our yield back in pounds. We want to be consistent with those other crops, because if we start doing different units here, and I'll give my own example. I grow nectarines. So industry standard 25-pound lug box. Nobody packs in a 25-pound lug box. We have single layer, we have the Costco box, we have the Walmart box. We have every box imaginable, but our packing house gives us a 25-pound equivalent. So when you fill this in, put the production unit on that sheet that says what your production unit, the consistent unit is. And each crop is going to be a little bit different. We went to the industry, CDFA, and looked at how are we reporting blueberries and carrots and all these other crops. Again, almonds, walnuts, and those other crops are real simple. But this is important for the data tracking that we're going to need to do. So running through this real quick, this is, you have a document here that's for planning. This column is planning. This is what you should have filled out last year, and we're not going to be counting if you haven't filled it out and do it when we send it. And then this is your actuals. It's off the screen here. And I'm going to just go over it real quick. So when you sit down with a CCA right now for 16 and you say, okay, I'm a 3,000 pound orchard. I get 25, sometimes 35, but I'm going to plan for 3,000 pounds of nut meats this year. So he's going to give you a pound per acre recommendation that he thinks you ought to use for 3,000 pounds of almonds. So that's where this information goes, and then the acres. Then the recommended amounts for each of these areas, the dry liquid, foliar, how many pounds per acre that you put on, the available, if you do compost manure, you estimate not, because we don't know in compost exactly how many pounds are, but there's ranges. You estimate how much is in manure compost, and if it's none, it's zero. If you don't put it on, then you'll total it here, and then this soil nitrogen. We've been able to convince the regional board that there's book values out there. The UC, the agronomist can tell you roughly 2 to 5 pounds of residual N in your soils if it's orchards and vineyards. If it's corn using a lot of manure, it's a little different story, but use book values, we call them. You don't have to go out and do a soil test. If you want to, it's good. I mean, that'll give you an idea, but you can use book values. Typically in the mineral soils, it's not very high. But we had to have it on here. But the N in irrigation water, if you put out 30 inches and you got so many parts per million, you can estimate about how much nitrogen is going to go on in your irrigation water. So at the end, at the bottom, the CCA is going to say, all right, I think you ought to put, for your 3,000 pound almonds, put on 200 units of N. So then that's what the CCA will be doing for you this year. Because on the 2016 crop, you need to, if you're in high vulnerability, you need to connect with a CCA or get self-certified, and I'll tell you about that in a minute, get self-certified to sign off on this. If you're low vulnerability, small acres, you don't need to do that. Okay, then now we're at the end of the year, we send you our summary report. What you need to do is then go back and what did you actually do? And you fill out this column. These are the areas that you're gonna transfer to that summary sheet and come up with your pounds per acre. So what did I actually, he recommended 200 and I put on 150 or whatever it is. So you put that there. And nobody's gonna say, he said 150, I did 200, because you may have crop differences than what you thought you were gonna have when you anticipated that yield early on in the season. So you just put on the actual, there's no right number, the right number is what you did. So you got your actual dry and liquid, foliar available. Again, that's probably going to be about the same. If you didn't put it on for some reason, it's 0. And then you estimate again, I put about 3 acre-feet of water. It had 20 parts per million. That's 100 units of N. So you go down and you're totaling this at the bottom of that column. This is your actuals. So then when the post-production actuals, your actual yield is going to be pounds per acre, tons, whatever it is, total N applied. And then this is where it's not N removed, it's going to be that A over Y. And again, I'm rushing through this, but there's some detailed instructions that we'll be sending to you that you'll get in the mail. And again, check with staff if it's confusing. We'll have some workshops too to help you walk through this. So this A over Y, I explained this already. This is something that we're using for a surrogate because we don't know what most crops remove. We have no idea, frankly. So we convinced the regional board to give them something. So that's what the A over Y will do. And then we'll take that number, the coalition, and calculate roughly how much nitrogen was removed based on the information we do know for the certain crops. Okay, so a summary's going out next week. Try to have it in by March 15. That's kind of a soft deadline. If you make it by April 1, that's all right. But when April 1 is when we turn it over to MLJ's group and they're going to start compiling this information. So please try to get this in. We don't want you to have to get the regional board asking us who didn't turn it in, so we got to get notified. One thing to remember, a point is, and this is probably common sense to all of us here, but if you put on triple 15 and you put 1,000 pounds per acre on, don't put 1,000 pounds of nitrogen that you put on your crop, because triple 15 is 15% nitrogen. So you put on 150 pounds. 21,714, you put 1,000 pounds, it's 210. That's a mistake. We have these self-certification courses. A lot of people are thinking my gross pounds of fertilizer. It's the percentage of nitrogen. And every label will have 21,714, 50. Okay, again, you know all that kind of stuff. And then the irrigation water, estimate, nitrogen and compost. I use compost. The guy who sells it to me says it's roughly 15 units of N. So that's what I plug in, is 15 units of N in my compost. Okay, here's some dates. We've sent these out already. If you want to do your own certification, you come to this course. It's a 4-hour course taught by trained CCAs. That's actually a very good curriculum if you want a refresher. And you can go to our coalition's meetings. If you're in another coalitions, they put on meetings. It doesn't matter where you take this course to be self-certified. So check out these dates. There's a 30-question test at the end, pretty straightforward. The pass rate's about 80% or so, so it's not super difficult. Most people are doing fine on it. And then you've got your annual reports. Leave your ballots, please, then we don't have to mail a ballot for our board members. And here's our phone numbers. Appreciate you showing up, and corner us if you got questions. Please stay for lunch. We have 500 servings there, so we have 600 people here, and appreciate you coming. Thank you.